All right. In this lecture, we will be discussing Fourier series. So, in this lecture, we will be starting with the basics of Fourier series. So, Fourier series is a series of representation of periodic function in terms of infinite summation of cosine and sine. That is it. So, with some constants, we express a periodic function in terms of infinite series having some cosine and sine terms where these constants can be seen as a naught as 1 upon pi minus pi to pi of x dx, an is 1 upon pi integration minus pi to pi of x cos nx dx, and bn is 1 upon pi integration minus pi to pi f of x sine nx dx. And we can express them as f of x equal to a naught plus summation n equal to 1 to infinity an cos nx plus bn sin nx. And this equation is actually true, and these limits and whatever, I think I am talking only with the context and the with specification of limits of x from minus pi to pi. For other limits, like in, let's consider a constant as L for some limits like integration 0 to L, or we can consider that if integration from minus L to L. The formula, there is a slight variation in the formula. The variation will be, instead of cos nx, we have to use cos n pi x upon L, and same thing we will do with the sine term. We will do as a sine uh, n pi x upon L. There will be a slight variation in the formula here, the pi. It will be from, like, if we consider as a limit as 0 to pi, don't worry if you are not able to understand here. We will be talking about these specific limits in next further lectures, so in upcoming lectures. So don't worry, I am just in a brief talking about those things. So the limits will be changed. So let's move. If you are not understanding, yeah, right here, so don't worry, let's move to our main thing, which is problem solving. And in further lecture, upcoming lecture, we will discuss about these limits and further half sine and cosine series, odd even functions, in a detailed manner. Don't worry. So let's start by taking this question as our first problem. Uh, Now we know that. Let's write the formula first. F of x equals to a naught plus summation n equals to 1 to infinity a n cos nx. Why I am using cos nx? Because the limit is from minus pi to pi. And b and sine uh, bn sine nx. So this, let me read this all and write it clearly. Mm, you will get the all the notes in the comment section after the lecture will be uploaded. So don't worry about the notes. I will provide you notes of this lecture. So here is our formula. So firstly, we are supposed to find the values of constant only. We are provided formula. Now we have to only copy and paste our constants here. So a naught will be 1 upon 2 pi integration minus pi to pi f of x is x dx. So just by intuition, you can clearly see this function is odd. It is an odd function, and for odd function limits from minus a to a, the value of this integral will be 0. So a naught will be 0. Now moving ahead to another constant which is an. An is 1 upon pi integration minus pi to pi this f of x times cos n x dx. Now let's see, this function is odd, so on f of minus x this will become negative, and on f of minus x this will become positive. So the product of this function is also odd, so we can just by intuition we can say for this one also this will be 0. Now moving ahead for our next constant and the last constant, which is bn. Bn we can write it as 1 upon pi integration minus pi to pi f of x sine n x dx. Now we can see here f of minus a is f of minus x is minus x, f of minus a is minus f of a. So the product of this function is even. So using the even integral property, we can just modify the limits and we can write it as a 1 upon pi. Sorry. Hmm, we can write it as a 2 upon pi integration 0 to pi x sine n x dx. Now only thing left for us is to solve this easy integral. So 2 upon pi we will get x times minus cos n x divided by n from limit 0 to pi. Let me make it clear, it is minus plus 1 plus 1 upon n in integration 0 to pi we will get cos n x dx. So whatever we will get on integrating, we will get sine, and sine from 0 to it we will get as a 0. So on solving this we will get bn equals to 2 by n pi 2 by 2 by n pi times minus 1 into minus 1 to the power n. So we will get let's simplify it, move further. Let's see, it will be minus 2 by n minus 1 to the power n. So it will be bn, our only coefficient which is not 0, bn. I hope everything is right and no calculation mistake I have made. Yeah, so yeah, everything is, I think, right. So now using Fourier series, we have to put the formula, all the coefficients So we will get a naught and a n is 0. So we will get summation n equals to 1 to infinity minus 2 by pi minus 1 to the power n sine n x. So here it is our answer. I hope you have understood it. It was the only thing problem with the Fourier series problem is they are a little bit lengthy. Otherwise, they are quite easy. You just have to find the value of these coefficients, and it is really easy to solve those integrals. Now, moving ahead to our next problem, which is this. It is a even function. So once we will go through it. Now I think you have got the formula, so I will directly write the value of these coefficients. So a naught 1 upon 2 pi integration minus pi 2 pi, this is f of x square dx. So this is an even function. We can write it as 1 upon pi integration 0 to pi x square dx, which we can write it as 1 upon pi, and it will write as pi cube upon 3, and we can write it as pi square divided by 3. So this is our a naught. Hmm. This is our a naught. Now moving ahead for our next constant, which is a n. So a n is 1 upon pi integration minus pi to pi x square cos n x dx. So this, the product of this function is even. We can write our integral as 2 upon pi by using the odd even property of this integration 0 to pi x square cos n x dx. Now in we let's solve this integral x square cos nx. I have a shortcut to solve this integral trick. Let me tell you how to solve this question. For um, cos nx. So this one is a first function and this is a second function. So we will have to write it as 2x 2 0. Keep on differentiating it. Now keep on integrating it. You will get sine nx divided by n. Again integrate this, we will get minus cos nx divided by n square. Again integrate this, we will get, sorry, minus of sine nx divided by n cube. Now just write it here as plus minus plus. Just do product like this, multiply them, and we will get do this multiply, we will multiply this, we will multiply this, we will get 2 by pi. So x square sine n x by n minus 2x, sorry, the product will be there positive, so 2x cos nx divided by n square, their product will be minus 2 sine n x divided by n cube. Now putting limits from 0 to pi. Now with intuition we can say from for sine limits, integration from 0 to pi will be 0. So only thing we will look here is for cosine limit. So we will get 2 by pi, and this will be 2 pi by n square times, on putting pi we will get minus 1 to the power n. So we will get our an as let me see once again, it will be, we will get pi to pi, we will get 4 4 minus 1 to the power n divided by n square. This will be our second equation. So we have got the value of a naught, we have got the value of an. Now it's time for bn. So bn equals to 1 upon pi integration minus pi to pi x square times sine n x dx. Now we can clearly see that this is an even function, and for such limit, and this is an odd function, so the product will be odd. And by intuition we can clearly say that for such limit our integral will turn out to be 0. So only a naught and a n are the required coefficients. So we will get f of x as f of x as a pi square of 1 3 pi square upon 3 plus summation n equals to 1 to infinity 4 minus 1 to the power n upon n square. Sorry, and we will get to, sorry, once again, cos nx, and here we have our answer. So this is our Fourier series representation of our function cos square x for the limit minus pi to the pi. Now moving ahead to our next question, and I think this will be our final question for next lecture. I will take more problems. So this is our question. So I have taken this question for piecewise function. Like if some paper in examination, teachers often ask questions based on piecewise function. So only thing you have to do is break your limit. So a naught is actually, let's see once again, a naught we know that is 1 upon 2 pi. A naught is 1 upon 2 pi integration minus pi to pi f of x and dx. So only thing you have to do is break the limit. So you will get 1 upon 2 pi, and this is integration from minus pi to 0 f of x of x dx plus integration 0 to pi, integration 0 to pi f of f of x dx. So here is our answer. So now only thing we will do same procedure, splitting of limit for an also and bn also. So now we will write it as proceed towards solving this problem. 1 upon 2 pi for limit minus pi to pi, minus pi to 0, minus pi to 0, we have our function as minus k times dx plus, for limit 0 to pi we have our function f of x as k times dx. On solving we will get 1 upon 2 pi minus k x from minus pi to 0 plus uh, k x from limit 0 to pi. So here we will get 1 divided by 2 pi. We will get this will be negative k pi plus k pi. We will from here we will get k by 2. So we will get a naught, it is a naught. Now moving ahead for an, we will get I will directly write the integral now. I hope you have understand it. Integration from minus pi to 0, we will get minus k uh, cos n x dx plus integration 0 to pi k times of cos n x dx. Now on solving we will get 1 upon just a second, 1 upon pi. Here we will get a minus k, it will be sine n x upon n from limit minus pi to 0, from minus pi to 0 plus in k times of sine n x upon n, limit from 0 to pi. Now once you will put the limit, you will find out that this whole term will tend out to be 0. So an is 0. Moving ahead for bn, so bn will be 1 upon pi. We will split the integral, so minus pi, so to 0. K is f of x is minus k times sine n x dx plus integration 0 to pi k times sine n x dx. So on solving this, we will get 1 upon pi. This is k cos n x upon n from limit minus pi to 0 plus, no, sorry, it will be it will be minus here. It will be minus k cos n x divided by n from limit 0 to pi. Now on putting limit, we will obtain 1 upon pi for 0, this k, so k for 0 limit, it will be 1 upon n. For minus pi, it will be minus of minus 1 upon n upon n. Now here k times of, for limit pi, we will get minus 1 divided by n to the power n. For 0 limit, we will get minus 1 divided by n. So now if we look through, so we can clearly see this is 1 upon pi. You can take k by n as a common, k by n as common, and you will see 2 minus 2 minus 1 to the power n. Simplifying it, we will get 2k 2k upon n pi, 1 minus 1 to the power n. This is bn. So now we can write our function f of x as a naught. We have got a naught as k by 2, a naught as k by 2 plus an is 0, bn summation n equals to 1 to infinity 2k upon n by 1 minus 1 to the power n sine nx. So this is our answer. We have expressed our function, piecewise function, in terms of Fourier series. So I hope you have understand this lecture. Understood the lecture. I have taken all the three important problems which I thought are necessary and which will be the most basics ones so you can understand easily. So this was the first one. This was the second one. This is our third one. So I am giving you this homework problem. This okay, we will take it as a this problem is a very nice problem. We will take this problem in our next lecture. Don't if you want to try, you can try. For show part, if you will be able, you just have to expand the summation series and you will get our answer. But don't worry, I will solve help this lecture in the next lecture problem. You have to solve this problem as a homework problem. You have to solve this problem as your homework problem, and you have to solve this problem as your homework problem. I am going to give you these three problems as your homework problem. So I thought I am thinking that you will solve these problems and we will comment your answer in the comment section. So we will meet in next lecture. Thank you and have a nice day.